In this video, I'm going to go over tectonic plate movement and how that's related to what we've been learning about earthquakes and then other natural disasters like volcanoes and tsunamis. So the first thing I want you to do is look at this map. This map is looking at all the earthquakes that happened on May 11, 2022, so last week. And I want you to observe where these earthquakes are mostly located. And after watching a video about the Ring of Fire, hopefully you recognize that the majority of these earthquakes are occurring on the edge of the Pacific Plate. And so, because of plate tectonics, there are these places that are more prone to earthquakes as well as volcanic activity and tsunamis. And so I'm just going to skip over this video because you already watched it. And so what you saw in the video is that we have these plates that are, the surface of the Earth is broken up into these plates, which implies that there are different levels or layers of the Earth's surface. And we'll talk about this more in our activity on the Earth's layers. But I did want to preview the different parts of the layer that are part of the surface and these plate tectonic movements. And so on page 10 of your Earth Science reference table, you'll see this diagram, and we'll mostly be focusing on this top part for right now. But the very first layer of the Earth, the most surface level, is the lithosphere. And the lithosphere is actually broken up into two parts, the crust and the rigid mantle. Underneath the lithosphere is the asthenosphere, and that's actually where convection occurs, which actually drives plate movement. And you can actually see that it's indicated on the diagram because you can see those circular arrows, which are what we associate with convection. And so that convection of that liquid in the asthenosphere is actually going to cause these floating plates on top to move back and forth. Under the asthenosphere is the stiffer mantle, then the outer core and the inner core. And like I said, in the activity later on in this activity list, you'll actually learn about the layers of the Earth. And so plate tectonics is just the idea that the lithosphere, or that surface layer, is cut up into pieces called plates. Those plates are named after the features that are on top of them. And so you actually can see that there are different plates called like the North American plate, the Caribbean plate, South American plate, things that you should be familiar with after doing the activity, looking at the plate diagram on your Earth Science reference table. And at the boundaries of these plates, where they are interacting, pieces of the plates are either created or destroyed. And so at those boundaries, we see a lot of earthquakes, volcanic activity, ocean trenches, and mountain range formation. And depending on the way that they're interacting, we have different types of plate boundaries. So the plates will move due to convection currents in the asthenosphere. And so, for example, in this GIF, you can see that we have in the asthenosphere, you have this liquid magma that's moving in the circular motion, and the plate that's on top is actually moving along with it. And as it's moving, there will be, depending on what is happening at that plate boundary, we're going to see different types of activity. So for example, when the plates are moving apart, we have what's called seafloor spreading. When you have a plate moving underneath another plate, which is called a converging boundary, you'll actually have the formation of volcanoes and mountain ranges because they're being pushed together. And then when they are moving past each other, you'll see a different type of activity. So just to remind you that page 5 of your Earth Science reference table is all of the different plates that the Earth is broken up into, as well as the different plate boundaries. And so if the plates are indicated by this type of double line and the arrows are moving away, that's a divergent plate boundary. If there are lines with these little boxes on them, then this is a convergent plate boundary, which is also called a subduction zone. And then you can see that where the boxes are, that's indicating the subduction zone. When they're pushing past each other, those are transform plate boundaries or transform faults. And then there are some where the type of boundary is unknown, so it's called complex or uncertain. And then the arrows indicate the relative motion. And then you see these little sun-looking things, which are hotspots. And those are just areas in the middle of plates where you have holes in the crust and the magma is coming up and forming a lot of times like these islands. So Hawaii has a hotspot. That's actually what formed the Hawaiian Islands. And so in this section, we're going to go a little bit more in depth into the different types of plate boundaries and why they're different. So the first, that what you saw on page 5, is the divergent boundary. And divergent means to move apart. So in divergent boundaries, the plates are forced apart by upwelling magma, and you get new bedrock formation. So a lot of times what you'll see is if it's under the ocean, you get what's called oceanic spreading. And so you'll have the newest rock right at the boundary. And then as you move away from the boundary towards the edges, that will be the oldest rock. A convergent boundary is where two plates collide or converge, and one subducts, which means to go underneath the other, which usually creates mountain ranges and volcanoes on land and trenches underwater. So when you have an oceanic plate, or a plate where the ocean is subducting underneath the continental or converging with the continental, the oceanic crust is actually going to go underneath. And that's just based on the difference in the type of rocks that make up oceanic crust versus continental crust. So the oceanic crust is always going to be forced underneath. Because you have two plates that are coming together, it's going to sort of crunch those together and cause these mountain ranges. And if there's any place where there's a weak spot underneath the crust, then the magma can come up into those mountain ranges and form a volcano. So if you recall from the Pacific plate colliding with a lot of the other plates around it, that's that oceanic crust is going underneath, which is why you have those volcanoes directly around the Pacific plate. And then the last boundary that you have to know is a transform boundary. And so instead of it being pushed together or drawn apart, you actually have them moving past each other. And so that's where two plates sort of collide and slip past each other. And so pressure is going to build up and the rocks will break. And then once they break, that's actually what's going to cause an earthquake. So as soon as they break, that's going to lead to those waves, those P and S waves that end up being the earthquakes that we feel. And so areas where you see a lot of transform faults, you're going to get a lot of earthquakes. So here's some checks for understanding. So you definitely need your earth science reference table. So the first question, it shows you the photograph of a San Andreas fault. And then the question is for you to say what type of boundary it is. And so if you don't know what the San Andreas Fault is or where it is, it tells you it's in the western United States. You're going to actually use page 5 of your reference table to go and find it. And so if you look on page 5, you can see that at the San Andreas Fault, you actually have the arrows are going past each other. So it's going to be a transform plate boundary. So it's going to be number 1. So again, if you're looking at your reference table, you look over in the western part of the United States, the San Andreas Fault is labeled, and you can see that the arrows are going opposite each other, and so that's going to be a transform plate boundary. So the next question asks for you to look at the block diagram, and it represents the formation of an island arc near a plate boundary. An island arc is located near the boundary between which two tectonic plates? So based on what's happening in this particular block diagram, you can see that there is oceanic crust that's subducting or going underneath continental crust. And so we're looking for a convergent plate boundary. And so we're going to go through each of the choices and look for the one where the two arrows are pointing towards each other to indicate a convergent plate boundary. And so if you look where the Antarctic plate and the Indian Australian plate is, they meet actually the Indian Australian plate and the Antarctic plate are going to meet right here, and you can see that the arrows are actually moving apart, so that's divergent, so it can't be number 1. For number 2, we're looking at the Philippine plate and the Eurasian plate. So the Philippine plate and the Eurasian plate are right here. And you can see that it has the line with the boxes, which is going to be a convergent plate boundary. So it could be that one, but let's check the other ones. For number 3, the African plate and the North American plate. The African plate is over here, and the North American plate is here. They sort of meet here in the middle at the mid-Atlantic ridge. They actually are moving apart. And you can see that that's a divergent plate boundary, so it's not number 3. And for number 4, Scotia plate and South American plate. So if we look at the South American plate, which is down here, and the Scotia plate, which is at the very bottom, they're actually moving past each other. So that's a transform boundary, so it's not going to be that one. So the correct answer is 2, because that's the only one that has a convergent plate boundary. And then for the last question, it tells you that the photograph below shows the East African Rift Valley in Africa, and then asks which tectonic movement of Earth's crust is most likely responsible for this feature. And so you need to, again, use your reference table to find the East African Rift Valley. And so that's all the way on the edge here. And you can see that the arrows are moving away from each other. So that's going to be divergence. So it can't be number 1 or 2. And so the question is whether it's divergence of continental crust or oceanic crust. And so the East African Rift is on a continent. It's not in the ocean. So the correct answer has to be divergence of continental crust, or 3. And so those are some examples of how you would use the reference table in order to answer questions about the different types of plate boundaries. And so at this point, you can go and then do the next activity and practice on your activity list.